All right, well, we're back here. I didn't realize I was going for 15 minutes, so um, part two of the video now. So I think we left off how far horizontally from the edge of the table. So we had horizontal velocity times time. So horizontal velocity was 5 meters per second given in the problem up here. And the time it was in the air was 0.63 seconds. So I'll multiply by 0.63 seconds. And that equals, where is it? 3.15. Yay, 3.15 meters. And then, so here does mass affect the flight of the ball? So we had talked about this with our angle launch projectile, but it doesn't matter if I have a 3 kilogram ball, a 10 kilogram ball, whatever it is, if it leaves the table at 5 meters per second, it's going to fly this exact same way. The mass does not affect the flight. It only affects how hard it is to get it to that initial velocity. So this is no effect on it. And then last page here, so we had these vectors, like we did these in class the other day, and I think we even did this example, but the key on something like this is making sure that you can match the horizontal velocity. So at E, if it gives it to you like this, then I know that these three right here are the only acceptable answers because horizontal velocity stays the same. So at position B, it's going to have a higher vertical velocity than it is at D because it slows down on the way up. So out of these three, and I said number them 1, 2, 3, 4, 5, 6. So this would be number 6. That means this set of vectors. That would be at position B. At position D, just before it gets to the top, it's going to have a little bit of vertical. So this is number 3. And then as it comes back down at H, so now the vertical component is downward. And so I'm going to say, let's see, that's 1, 2, 3, 4, 5. So this is the one that would go at position G. And then here, this related to stuff we talked about from the pair deck. So the acceleration at point E at the very top is 10 meters per second squared. So that acceleration is always due to the force of gravity, which is always on this object. And so how does that compare at position B, at position G? And so some kids had previously thought that those were different, and so I just really wanted to make sure that you knew that those were the same. So the acceleration is constant throughout, even though the velocity is not constant, at least the vertical velocity. And then what forces are on the object at position E? So at the very top, it's just the force of gravity. So, and that is then the net force, because the net force is all the forces, and if the only one's gravity, then the net force and gravity are the same. And how does that compare with C and H? Well, that's the same as well. So there's no other forces, and if you're putting air resistance here for 16B, we gotta give that up, right? And then here we match the timers. So here this one has an initial velocity at 0 seconds of 30 meters per second up and 30 meters per second to the right. So 1 second later, the horizontal doesn't change, but if this is going up, it's going to decrease by 10 on the way up. So after 1 second, we're going to be at 20 meters per second up and still 30 to the right. So that's box number 5. 3 seconds after this, so the only one that's going to change is the vertical, and it's going to go from 30 to 20 to 10 to 0. So it's going to be at the peak height with 0 vertical velocity, but horizontal stays the same. So that's box number 4. And then lastly, 6 seconds later, so it took 3 to go up, it's going to take 3 to come down. So now I'm going to have a vertical component that is downward, 30 meters per second. My horizontal stays the same, so that's box number 2. So we're at box 2 there, and I think that's it. Oh, there's 4 pages? I thought it was 3. Maybe it's because I zoomed in, right? No, that wouldn't do it. But anyways, hey, I hope you have a great Sunday today, and I hope you're ready to rock this assessment. And let me know if you have other questions.